How NASA fixed a dying camera 370 million miles away with heat. Imagine trying to fix a camera millions of miles away from Earth when every attempt seems doomed to fail. That's precisely what NASA faced with their JunoCam on the Juno spacecraft, orbiting Jupiter over 370 million miles away. Initially designed to last for just 8 orbits, the camera defied expectations by making it through 46 orbits. However, orbit 47 brought challenges, as radiation damage began to show, threatening to blind one of Juno's primary eyes on Jupiter's dynamic storms and moons. At NASA's Jet Propulsion Lab, engineers identified a suspected fault in the camera's voltage regulator, likely damaged by the intense radiation field surrounding Jupiter. Given the spacecraft's distance from Earth, swapping hardware was impossible. Instead, they turned to a surprising solution: heat. The team decided to apply annealing, a technique often used in materials science to reduce microscopic defects by heating and then cooling a material. They used JunoCam's onboard heater to raise its temperature to 77 degrees Fahrenheit. Miraculously, the camera began to function again, capturing clear images. However, this fix was temporary, and by orbit 55, the images became corrupted once more. With a crucial flyby of Io, Jupiter's fiery volcanic moon, approaching, the team faced a high-stakes decision. They opted for a riskier method, cranking the heater to its maximum setting. Days passed with little improvement, but just before the December 2023 flyby, the images cleared up, revealing stunning details of Io's North Polar region, including sulfur dioxide frost-covered mountains and newly formed volcanic flows. This daring repair not only saved the Io flyby but also opened new possibilities for spacecraft maintenance. NASA has since applied this technique to other Juno instruments, although they haven't disclosed all the outcomes. According to Juno's principal investigator, Scott Bolton, we're learning how to build spacecraft that can withstand radiation. This knowledge will impact everything from Earth-orbiting satellites to deep space probes and defense systems. JunoCam has now endured 74 orbits, but as the mission delves deeper into Jupiter's radiation belts, image quality is deteriorating again. Whether further repairs are feasible or worthwhile remains uncertain. For now, NASA's ingenious remote repair has extended the mission, provided valuable data, and offered a rare glimpse into one of the solar system's most extreme environments. NASA saves JunoCam, a deep space repair 370 million miles from Earth. In the high-stakes world of space exploration, even the tiniest glitch can mean the difference between groundbreaking discovery and mission failure. Imagine this: a sophisticated camera, over 370 million miles away, orbiting a radiation-blasted giant like Jupiter, suddenly starts malfunctioning. Can you really fix something that far away? NASA's Juno mission team says yes, and the way they did it might just change the way we protect all future space technology. But here's where it gets controversial: not everyone agrees this method should become the gold standard. Back in December 2023, the team behind NASA's Juno spacecraft needed to recover their precious JunoCam, a visible light, color camera positioned outside the spacecraft's titanium radiation shield. The mission was critical: capture priceless images of Jupiter's fiery moon, Io. Their success, and the lessons learned, were unveiled during a recent NASA technical session at the Nuclear and Space Radiation Effects Conference in Nashville. Even now, the space community is buzzing about what this could mean for every satellite and deep space probe facing radiation threats. Let's set the stage. JunoCam was placed outside the protective vault to get the best possible images for the mission. This means it's exposed directly to some of the most punishing radiation fields in our solar system. Initially, engineers believed JunoCam would survive at least the first 8 orbits of Jupiter. But after that? No one could say for sure. Remarkably, for 34 orbits, everything went smoothly. JunoCam provided a steady stream of stunning images, fueling a host of scientific papers about Jupiter and its moons. Then, in the 47th orbit, an ominous sign appeared: JunoCam's images began showing subtle signs of radiation damage. By the 56th way around the gas giant, images were almost completely ruined. It was a nightmare scenario: billions of dollars invested, hundreds of millions of miles from Earth, and critical instruments failing. Identifying the source of the problem wasn't easy. Although radiation damage was suspected, Diagnosing the precise failure point from such a distance is no small feat. Clues eventually pointed to a faulty voltage regulator that's essential for powering the camera. With few options left, the team decided to try annealing, a process where you heat material, in this case, likely a silicon component, to a certain temperature, then let it cool slowly. The science behind exactly how annealing repairs space electronics is still debated, but sometimes it works wonders. Jacob Schaffner, JunoCam's imaging engineer at Malin Space Science Systems, described the nerve-wracking gamble. "We ordered JunoCam's heater to bring the camera up to 77 degrees Fahrenheit, a lot warmer than its normal operating temperature, and then just waited, unsure if we'd see any improvement," he explained. For a little while, they waited, holding their breath. Amazingly, the gamble paid off. The images grew sharp again and, for several more orbits, the camera performed beautifully. But the relief was short-lived. As Juno dived deeper through Jupiter's radiation, the problems soon resurfaced. Images became streaky, plagued with noise. Every fix tried on the ground made little difference. So, when a close encounter with Io, the most volcanic world in the solar system, loomed just weeks away, the team faced what instrument lead Michael Ravine called a Hail Mary play, maxing out the heater to push the annealing process to its extreme limits. The first week, there was little hope. Images trickled back with almost no improvement. Then, just days before the critical Io flyby, something extraordinary happened. Image quality skyrocketed. JunoCam captured high-resolution, near-perfect photographs of Io, including its North Pole, revealing breathtaking details like sulfur dioxide-tipped mountain blocks and rivers of lava, features never before seen with such clarity. But here's the part most people miss. As of the spacecraft's 74th orbit, and counting, the problem has cycled back. JunoCam's noise returned, reminding everyone that in deep space, nothing is ever truly fixed for long. Still, the team didn't stop at JunoCam. They've started applying annealing to other Juno instruments, hoping to squeeze more life out of several engineering subsystems. Imagine, techniques born out of desperation on one Jovian mission could soon help make every Earth-orbiting satellite more resilient. Scott Bolton, Juno's principal investigator at the Southwest Research Institute, put it this way: Juno is teaching us how to design spacecraft that can better withstand radiation, and these lessons won't just help NASA, they could also impact military and commercial satellites. That means your cell phone or TV signal, relayed via commercial satellites, might one day depend on a fix first tested millions of miles away by a science probe zapping Jupiter. Now, here's where debate ignites. Should mission designers build more robust, heavier systems from the start, or should they continue pushing the limits through repairs like annealing? Is this just a clever workaround, or proof that flexibility beats rigidity in space engineering? What do you think? Is NASA's approach brilliant risk management, or should we demand a more fail-safe standard from the outset? Share your thoughts. Would you trust a spacecraft your life depended on to such improvisation, or insist on nothing but the very toughest tech? If you want to dive deeper into Juno's ongoing journey and its breakthrough discoveries, check NASA's dedicated mission hub at https://www.nasa.gov/Juno. And if you've got a strong take, pro or con, on how we should build the next generation of space explorers, let your voice be heard in the comments below. NASA's bold repair: how JunoCam survived Jupiter's harsh environment. Breaking news: in a move that redefines the limits of space repair, NASA has ingeniously revived a malfunctioning camera on its Juno spacecraft orbiting Jupiter. Facing the daunting reality of 595 million kilometers between Earth and its distant probe, the engineering team dismissed the idea of a hardware replacement and instead opted for an innovative technique known as annealing, a method that involves carefully applying heat to repair electronic components on a microscopic level. Originally built to withstand only 8 or